All right, so this is day 36, limiting reactant practice. Hopefully this is getting slightly easier, and today, hopefully it will be easier. We're going to finish practicing this week a little bit, and then next week we will start working on the final exam, and then turn that in, and then you are done. All right, so first thing, what mass of hydrogen gas can be produced if 12 moles of sodium react with 8 moles of water? Okay, so remember that when you're using the BCA table, everything must be in moles before you start. All right, so if it's not in moles, then you need to do a conversion. But here we see that the sodium is given in moles and the water is given in moles. So we don't have to do any pre-conversion. We're ready to just go to the BCA table. Okay, all right, so first thing is that we need to balance. So I have sodium plus water makes sodium hydroxide and hydrogen gas. All right, so when you see this is a single replacement, okay, and one of them is water, then it might be easier to think of water as an H and an OH for balancing, right? Because see here you have an OH, that makes it a little bit cleaner, okay? So over here, I have one hydrogen, not counting this one, right? Because this is part of the OH, one hydrogen, and here I have 2 hydrogens. So this is gonna have to be a 2, okay? So then I have 2 hydrogens here, 2 OHs, but here I only have 1 OH. So this is going to have to also be a 2, which gave me 2 sodiums. So this has to be a 2, and then this is going to be a 1. All right, so I'll just go back and double check it. 2 sodiums, 2 sodiums, and let's just look at the hydrogens total. So now I see I have 4 hydrogens, and I have 2 here and 2 here, so 4 total, 2 oxygens and 2 oxygens. Okay, so I'm ready to go. All right, so go ahead and fill in my befores. Okay, the moles of sodium and moles of water are given, and the products are always 0 when you start. All right, and now we have to determine which one is the limiting reactant. Okay, this one's fairly easy because, see, this is a 2-to-2 ratio or 1-to-1, right? You need the same amount of them to run the reaction, okay? And I clearly have plenty of sodium, but less water. So in this case, I know that water is going to be my limiting reactant. So I'm going to go ahead and fill that in. Okay? Right? If you pick wrong and it's not coming out right, then just go back and pick the other one. Okay? So it's not magic. You just have to try it. All right? So since I'm going to be using up all 8 moles of water, that's going to become my given in the change table. Okay? So I'll go ahead and highlight like I've been doing. So that's going to be the given. All right, and then I'm going to look at the ratios. So every 2 moles of sodium requires 2 moles of water, okay? Every 2 moles of water is going to make 2 moles of this and 1 mole of hydrogen. Okay, so remember the given is what goes on the bottom. All right, that's this. That's my given, okay? And then I'm just going to bring down this 2. I'm going to bring down here. Bring this 2 down, bring the hydrogens 1 down. Okay, so this is going to be -8, this is going to be +8, and this is going to be +4. Right, so the amounts that I'm using, 8, 8, 8, 4, are the same as 2, 2, 2, 1. All right, okay, so now this is where it's a little bit trickier because now we're not just going to write excess, we want to know the amount. Okay, so here 12 moles of sodium I started with, but I only used 8. So then I'm going to have 4 moles of sodium remaining, okay? I'm going to make 8 moles of NaOH, and I'm going to make 4 moles of hydrogen, okay? All right, so I already filled out that water is my limiting reactant because that runs out first. And type of reaction, this is going to be a single replacement, right? Because the hydrogen replacement, the hydrogen and the sodium have switched places, okay? So for the word equation, right, I'm going to say 12 moles of sodium react with 8 moles of water, okay, to form 8 moles of sodium hydroxide. Right, that's a polyatomic. You're looking at the back of your pink sheet. And 4 moles of hydrogen. Okay, Now, what I want to say is this. Okay, that's the other new piece to this. Then I'll say 4 moles of sodium remain. Or there are 4 moles of sodium left over, something like that. Okay, so I want to hit all those numbers. Okay. All right, is the final answer to be in grams or moles? Okay, it asks for the mass of hydrogen. Okay, so I'm going to need to do one more conversion. So I'm going to start with 4 moles of hydrogen. And then I'm going to need to use molar mass to convert that. So 1 mole of H2 is 2.02 grams of H2, right? Because hydrogen's 1.01 times 2. Okay, and then that's going to be 8.08 grams of H2, and that becomes my final answer. Okay. Good? All right, let's try another one. Okay, make sure you're filling these out, okay, because you need to practice. Okay, let's try this one. What mass of excess reactant remains, okay, that's a little different, when 856.75 grams of BaOH2 is reacted with 218.76 grams of HCl. Okay. All right. So let's go ahead down here and look at our equation. So I have my HCl, BaOH, and that's going to form BaCl2 and water. Okay. All right. Before I can use the BCA table, I have to see what I have. So I have 856.75 grams, okay, of BaOH2. And I have 218.76 grams of HCl. Okay, so now I need to use the molar mass so I can put these into mole so that I can use the BCA table. Okay, all right, and I'm just going to go ahead and Google those molar masses. Again, make sure as long as you can find it, then that's fine. Okay, so molar mass of BaOH2, just make sure you get the right thing, is 171.34 grams in 1 mole. Okay, so that's going to give me, what's it going to give me? 856.75 divided by 171.34. It's going to give me 5. Okay, and I made all these numbers really simple, I think. Okay. And then HCl, that one's a little easier. That's just a hydrogen and a chlorine. It was like 36 point something or 35 point something. 36.46 grams of HCl. Okay, so I'm going to convert this to 6 moles HCl. Okay, so that's what I'm starting with. All right. So let's go ahead and balance the equation to start. So again, I see this water, so I'm going to turn that into an HOH to make it a little bit simpler. Okay, over here I see I'm going to have 2 OHs on the left. I only have 1 on the right. Let's get a new color. I'm getting bored of this color. So that's going to get a 2. Okay, which is going to give me, if I have here 2 OHs, I'm also getting 2 hydrogens from that. But over here, I only have 1. So this is going to need to get a 2, which also gives me 2 chlorines now, but it already has 2 chlorines, 1 barium and 1 barium. So we should be good to go with that. Okay, so I have 4 hydrogens over here, or sorry, 2, 4, 4. Yeah, all looks good. 2, 2. Yep, good. Okay, all right, so let's go ahead and write what we have. So we're starting with 5 moles of barium hydroxide and 6 moles of HCl. Okay, so we need to decide who the limiting reactant is going to be and who's going to run out first. Okay, so you can kind of reason it out, but again, if you're not sure, then just go ahead and pick one and do it. Okay, and then if something comes out negative, you know it's wrong. Okay, so I'm going to try to reason it out. So if I have 2 HCl's here and only 1 barium hydroxide, right, that means I'm going to need, if I want to use all 5 of these, I need twice as much HCl. Okay, so instead of 5, right, 1 became 5, 2 would need to become 10. Okay, I don't have nearly that much. Okay, I do have more HCl, but I don't have double the amount. Okay, so that indicates that that's going to run out first. Okay, all right, so then I'm going to go ahead and do my ratios. based on that amount. Okay, remember I started with 0 in the products. Okay, the given goes on the bottom. So since this here is a 2, that's going to go on everyone's bottom. Okay, and then I'm going to pull down the coefficients 1, 1, 2, right? Because I only need, whatever I have of this, I only need half as much of this, right? So this number here should be getting smaller. So 6 times a half is getting smaller at -3. This is going to be a +3, and then this is just going to be a 6. Okay? All right, so for the barium hydroxide, I started with 5 moles, but I only needed to use 3 before the HCl ran out. So that's going to give me 2 moles of barium hydroxide are going to be left over. Okay, for my products, barium chloride, 0, I got 3. Started with 0 waters, and I got 6. Okay, so my limiting reactant is HCl. Okay, type of reaction, hopefully you're recognizing this as a double replacement, right? Because they both start as ionic compounds and they're going to switch partners, okay, right? The HOH, the hydrogen switches. Okay. All right, now my word equation, all right, I'm going to say 6 moles of hydrogen chloride. Okay, if you want to say hydrochloric acid, that's fine too. React with 5 moles of barium hydroxide. Okay, none of these need Roman numerals, but you need to check that because a lot of you guys missed that on the quiz. Okay, so check to see if it needs a Roman numeral. Well, barium does not because it's in column 2. Okay, to form 3 moles of barium chloride and 6 moles of water. Okay, new thing we want to talk about is what's left over. 2 moles of barium hydroxide remain, right? Because here, right, I'm getting left with 2 moles of barium hydroxide. Okay, all right, so let's look back at what we're looking for. What mass of excess reactant remains? Okay, so if the HCl is the limiting reactant, that means the other one, the barium hydroxide, is the excess reactant, right? Because 2 moles of barium hydroxide remain. So that's what we're going to base our calculation on. Okay, so 2 moles barium hydroxide, but I want to know the mass of it. Okay, and I already got the molar mass up here, right? 171.34. And then calculate 342.68 grams remain. How much was there to start with? Oh, 856. Geez, that's a lot. Okay, so my final answer is going to be 342.68 grams of barium hydroxide. Okay, all right, now you're going to do the next. There are 4 more you're going to do on your own. Okay, please do them first, and then I'm going to link video solutions below. Okay, but please try to do them on your own. Okay, just watching me do it is not as good as you doing it on your own. Okay, lovely.